Hey folks, welcome back to Sourced by Cofactr, the show that cuts through the noise and gets to the good parts. I'm Ed Dodd. Great to have you with us again. So last time we talked about that big picture shift in procurement, right? Moving from just a cost center to something actually, strategic, the quiet revolution as we called it. And remember that wild stat, 73% of companies still leaning on spreadsheets? It's amazing. It shows just how much potential is still out there. But today we want to zoom in, get a bit more specific, because while those generic procurement tools, your Coupas, Arebas, that sort of thing, are great for, say, office chairs or software licenses, they really, really struggle when it comes to the nuts and bolts of electronics manufacturing. It's just a different beast entirely. Think complex bills of materials, strict compliance rules, constant supply chain risks for tiny components. Generic tools, they often just, fall flat. So today we're going to look at 7 really critical things that these generic platforms just cannot handle effectively in the world of electronics. This is basically a shortcut for anyone in hardware to understand why specialized electronics-focused tools are very different, so you can make an informed decision. Get ready for some, hopefully some aha moments. Let's dive in. First up, how these systems treat the bill of materials, the BOM. Generic platforms tend to see it as just a static file, like a fixed shopping list you upload once. Very transactional. You upload it, you execute the buy. This is okay for simple procurements, but in electronics, a BOM is alive. It's constantly evolving. It's this detailed blueprint, and every single line item carries risk. Availability questions, compliance needs. It's incredibly dynamic. If your platform isn't updating in real time with supplier data, flagging risks on the BOM itself, it's basically outdated the second you hit send on an RFQ. You end up designing with yesterday's news, which leads to delays, redesigns. Hey, it gets expensive fast. So let's contrast that. What do the specialized electronics native platforms do differently with the BOM? Well, they put the BOM right at the center of everything. It's the core. You see live stock, live pricing from, sometimes 40 plus distributors right there in your BOM view. You get instant alerts, life cycle warnings, compliance flags, sourcing risks. You can generate RFQs, POs straight from the BOM, trace, receipt, inventory fulfillment, all linked back to each specific part on that BOM. It becomes this dynamic, intelligent sourcing tool, not just a list. Okay, that leads nicely into the second point, specifically obsolescence and lifecycle risk. Generic tools are simply blind to this, completely blind. They just don't track part lifecycle stages like, active, NRND, end of life EOL. They don't see product change notifications, PCNs, or forecast EOL risk. That sounds like a huge liability. It is. Just look at 2023. Over 473,000 parts went EOL. Think about that number, 473,000. And you already know the really scary part. A single obsolete part, maybe a tiny 7-cent component, can force a product redesign, and the average cost for that, around $43,000. For a 7-cent part, that's a massive hidden cost. And worse, maybe 30% of these EOL parts give zero warning. Your generic tool happily approves a PO for a part that's already obsolete, maybe with a 52-week lead time. Disaster waiting to happen. But specialized tools, they build this in. They bake it right into the workflow. Risk scores per part, visual flags to the dangerous ones, last time buy dates, proactive suggestions for replacements. It's about prevention, not reaction. Getting ahead of the crisis. Okay, so what happens when prevention isn't enough and a part you need is just gone, out of stock? Point 3, suggesting alternate. Generic tools fail here too, miserably. If your chosen MOSFET isn't available, the generic platform basically just shrugs because it doesn't understand the specs. It has no electrical engineering smarts. It can't suggest alternatives based on form, fit, function. It can't match by footprint or core parameters. It just sees a part number. And during shortages, that's crippling. Specialized tools, though, they cross-reference hundreds of millions of parts. They can find drop-in replacements, parts with compatible specs, second source options, and check stock across suppliers, regions even. Being able to quickly pivot to an available, compliant alternative, that can literally save a production run. We're talking maybe $30,000 saved right there. That's a clear ROI. Okay, point 4. Compliance. How do generic tools handle things like ROWS or REACH? Most track compliance at the vendor level, which, is fine if you're buying paper from Staples, but if you're building a PCBA with parts from maybe 11 countries and 8 different suppliers, vendor level isn't enough. You need component level compliance. Every single part needs to be checked for ROWS, REACH, conflict minerals, maybe automotive AEC-Q standards. Even country of origin. With generic tools, that usually means you're chasing down PDFs, endless emails back and forth with suppliers, and hoping you don't fail an audit later. Specialized tools store compliance data per manufacturer part number, the MPN. They auto-flag non-compliant parts. It's integrated, built in, not bolted on. Makes sense. Okay, let's talk physical handling. Point 5. MSL, ESD, traceability. Generic tools don't even know what those acronyms mean. They track a purchase order, sure, but they have zero concept of how sensitive electronic components need to be received, stored, and handled. Moisture sensitivity level, ESD protection, forget it. And that's non-negotiable in electronics, right? You can ruin components with improper handling. Teams need software that understands MSL requirements, ensures ESD-safe procedures, tracks parts down to the lot level for traceability, watches shelf life exploration, knows about humidity control. Things generic software just isn't built for. Specialized tools embed all this. They integrate handling requirements into receiving workflows. Some even link up with 3PLs, third-party logistics providers, to ensure every single component is received correctly, bagged properly, barcoded, traceable from the PO right to the bin. Okay, point 6 feels related. Generic tools track the PO, but then what? Do they know if the parts actually arrive? That's the gap. They stop at the PO. They handle the request, the order, maybe the invoice match. But physical inventory, what actually landed on the receiving dock, where is it? Is it inspected? Ready for the build? Crickets. Total silence. It creates this massive blind spot between we ordered it and we have it ready to go, which must drive hardware teams crazy, constantly. Specialized platforms close that loop. Real-time inventory visibility, notifications when parts arrive, barcode scanning for traceability, kitting information, knowing what's ready to pull for a build. It connects the digital order to the physical reality, bringing the physical inventory online, essentially. All right, last one. Number 7, and this feels fundamental. Connecting engineering to procurement. Generic platforms usually assume procurement is this separate function operating in its own silo. But in hardware, the choices start way upstream, right? In engineering, when an engineer is picking parts in their CAD tool, Altium, Cadence, whatever, if they choose a part that's risky, nearing end of life, super expensive, or has only one source, procurement just inherits the problem downstream. They inherit the mess. And the generic procurement tool offers no way to fix it early on during design. It leads to those frantic last-minute scrambles, delays, higher costs. The whole design to procure loop is broken. So how do specialized tools bridge that gap? They integrate directly with engineering workflows. You can upload BOMs straight from CAD. Engineers get visibility into life cycle, cost, and sourcing risk while they're selecting parts, so they see the impact immediately. And the token suggests better alternates before the design is even finalized and released to procurement. It enables that shared view, that collaboration between engineering, procurement, and logistics. It tightens the whole process up. That's so transformative. Okay, so let's pull back. We've gone through 7 pretty significant shortcomings. What's the big picture here? The big picture is that electronics procurement is just fundamentally more complex. It's not ordering paper towels. It's managing intricate, high-stakes supply chains at the component level. It reminds me of, sales teams needing a CRM or engineering needing version control. It's the right tool for a complex job. Why would procurement handling BOMs worth hundreds of thousands, juggling global suppliers and constant risk, be stuck with generic tools or spreadsheets? It doesn't make strategic sense. Procurement teams are managing risk, cost, compliance, and continuity. They need tools built for their specific reality. Tools that understand electronics. They need tools that understand what a BOM actually is in this context, which really brings us to the cost of not making a change. The hidden costs we talked about. redesigns, delays, risks. That cost of inaction, the waste, the missed opportunities, the sheer risk exposure, it almost certainly outweighs the investment in getting the right tools. Without them, you're honestly flying blind. So, summing up, generic procurement software, it just doesn't cut it. The specialized needs of dynamic BOMs, lifecycle tracking, component level compliance, handling requirements, inventory visibility, the engineering link, they demand tools built for purpose. Success today isn't just about what you buy, it's about how you buy it. How intelligently, how efficiently, how resiliently. It's about the process and the visibility. So, for everyone listening, maybe take a hard look at your own operations. Are you trying to force a square peg into a round hole with your electronics procurement? Hopefully, this gives you some things to think about. Maybe it encourages a closer look at tools that genuinely get the complexities of electronics. Thank you all for joining me on Sourced by Cofactr. I'm Ed Dodd. I hope we cut through some noise and helped you get to the good parts. If you found this episode valuable, please subscribe and follow Cofactr for more hardware insights. Leave your questions in the comments and sign up for our newsletter at cofactr.com.